Hello and welcome to the channel. Right, this is going to be part one of our multi-channel DVM. I'm starting off very basic and be going through most of this. I will not be showing you how to install libraries into Arduino. You can Google that. And I am going to be using today the good old Mega. Right, here we are. We've got our nice Lego board, which I'm still loving. And we was going to use this voltage 16-bit analog to digital converter. I wanted 16 bits. The Mega's only good for 10, but I'm going to be using this in differential mode. Right, as usual, never prepared. That's probably what a lot of you like about this channel. Right, let's start. Let's see what we've got. Right, what I'm going to do is, like in the previous episode, I did say that I was going to make some buzz bars, which I have done. So let's move this. I'm going to have this as my 5 volts. All the colours, I did do black. And yeah, should I do it down here? Yeah, that is my ground. So let's plug that into the ground. This one into 5 volts. Actually, if I was really nice, let's try and feed that. It's not happening. See if I can feed that around the brick. Aha, might do. Got it. Okay. 5 volts. Let's do the same to that one. Missed the brick. And ground. Right, so I've got my buzz bars on now. It allows me to tap off a lot more. I probably won't use it in this episode, but we'll do in the next one or so. Right, let's plug our A to D there. And let's have a look what we got. Would you believe it? I'll have to remove a screw because I cannot see what the writing is. This is typical. Screwdriver. V and G. Okay, right, got it now. Got it. Right, so there's a ground. Is that going to be big enough? No. I have bought a whole assortment of cables. Right, what do I want? Let's try these ones. Right. I'll plug in ground there. Right. There's ground there. Should we have a red? Keeping with the colour scheme. Right. Red to red. Okay. I'm going to have a white. Now this goes onto the address line, and if I take this low, it will be module 1. Oh, it's knocking everything everywhere. And all we need now, oops, no, not one of those, some short ones. Right, this is the SCL and SDA. Let's just connect them. Try to anyway. Alright, what's what? SCL is the orange and SDA is there. So they're connected to SCL, SDA down on 20 and 21. And just for a bit of a reference voltage, let's have a look. 1, 2, 3. That's 0, 1. I'm going to put that in 3.3 and that one in ground, I think. That's so when we get some information out of here, it will be measuring the 3.3 volts. So hopefully when we do a bit of code, we can actually pull that and see how it looks. Right, let's just power up the Arduino. It ain't going to do diddly at the moment, and come back up to the computer. Right, let's have a look. We got that. There's that. Let's do a bit of work. Right. Right, what I'm going to do, let's bring this up. We've got the Arduino up. I have actually put the library in, so we're just going to do file examples and find out where its examples are hiding. Oh dear, was that on? No. There it is. It's here. Don't want to compare it to. I'm not having single-ended. I'm going to have differential. Single-ended would give us actually 4 inputs, but they'll all be which would be fine if you're using the same ground. I'm going to turn these modules into 2 differentials because I don't really want the chance of a ground issue when it's used eventually. And basically inputs 1 and 2 become the positive and negative of like channel 1. Right, let's have a look what we've got here. Let's open this up. Okay, it's going to come to the serial port, which is good, but I will show you that. That's always helpful. And we've got all different gains depending on what voltage you're measuring. So we need to just let's do this one. So I'm going to be doing plus or minus 6.14 volts. You must remember, right, we're using that module there, so we need to say that we're using that module somewhere. Oh, that's at the top here actually. So we don't want the 1015, we're using the 1115, so tell that the 16-bit version. So that's how many millivolts per count there is. So let's go to copy. And what's this actually do? Gets the results of channel 1. Okay. So that's between 0 and 1. I can't remember what I connected to, but if I do This is where I actually just take the example sketch and make it do what I want to do. This another variable 1. Actually, let's change that. That's going to be CH1 for channel 1. This is going to be CH2 for channel 2. So CH1 will equal that. Control C, Control V. Channel 2, I am presuming that would then be 2 to 3 within the inputs. Okay. Print differential. Yeah, don't care about that. We already know we're doing a differential. Print results, we changed that to channel 1. Let me say CH1. Let's do that. And it's in millivolts. Okay. Control C, V, similar line, channel 2. Blah 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 blah. Don't that will compile. Right, let's have a look. That's an open bracket, so let's put in millivolts. So results, results, no, it's CH1, isn't it? CH1 times multiplier. Okay, where's multiplier? CH2. Oh, right, here, multiplier. Okay. So what we want is not that one. I would have said we probably need that one because there's the multiplier which relates to that there. Okay, let's should have made this bigger. You probably ain't seen anything I've done there, have I? Oh dear, sorry about that, chaps and chapettes. Right. Right, let's just get that there. You can just see the LEDs there. Let's see if this compiles and uploads. Right. Come on, come on, come on, come on, come on. Okay, it's compiling and it's thrown it in. Okay, let's make this screen a bit bigger. Having troubles with mouse issues here. Don't want that. Right, now I should be spitting things out of serial port. No one's ever used that before. Right, what you do here is you just go to serial monitor. And what's that? That's bringing up that. Okay, we're not working too well there, are we? Why are we not working too well? Okay, let's have a look at the code. Let's get rid of the serial monitor. Right, so channel 1 times multiplied. Okay, channel 1. We obviously forgot something really radical. Well, we may be connected up wrong. Let's just hold on. That's not actually plugged in. That doesn't help, does it? Okay, that might be. Let's get to serial monitor and see if that's changed anything. Well, serial monitor. Oh yes, that has changed everything. If if you have a look now, you've got 2 channels, and this one is minus, so I'm going to swap those over. I mean, hold on. Let's flick those around, and it would be that one. That's the 3 volts we're measuring, so that should have gone positive now. I don't like the way that it's displaying, so let's get rid of that serial monitor. Let's have a look what we got. I don't need to actually print that, did I? If I do that, and a space, oops, nope, space inside the bracket, so hopefully that'll give us CH1, CH2, space. I'm not worried about the open bracket, which means I can get rid of that bracket, I think. Volts. Change the tag at the end to volts and put a space. Right, so that's that. So what we need to do is, that's a good maths equation, put it in a bracket, divide it by 1000. That should give me volts. So again, for that, because we wanted to work that out first, and then we want to divide it by 1000, so that will give me volts. So if we upload this sketch now, let's just do this so I can see when it starts the program. I have cocked up somewhere, missing character. Alright, okay, didn't want that, don't want that, don't want that. Okay, try that. I had left the brackets in and I was having a bit of a pissy fit. It's still having a pissy fit. What have I got? I bet a lot of you out there have seen what it is. Print 1 2 1 2. Missing terminator character. Right, okay, terminator, yes. Yep. There he goes, chaps. Now try again. Oh, again. There's a block before block. Right. Okay, let's print that. Oh, come on, where are you? Okay. Can't see it at the moment. Let's just unhighlight. Turn that into a thing. Is the top line okay? No, the top line is still not okay. That. Do that. Oh, we don't need to print ln, do we? Let's try that. Oh, I just had to pause then because the doors came in clattering around. Right, where are we? Right, I found out what the problem is. I needed some more bracket. What I need to do is get rid of this ln. Didn't need that, and these needed to be bracketed like these front ones here. So hopefully that will work. Have confidence, because I've hit the button to send it if it's good. Oh, Didn't see if it flashed. I'm going to do that again because I'm trying to move the screen. Right, let's see if this lot flash. Okay, yeah, seems happy. Alright, okie dokie dokie dokie. Alright. Let's make this a bit bigger for you. And now we go to tools. Serial monitor. Okay, we need a new line there. Okay, so let's do LM then. So that's obviously a line LM. Right. Let's see how we go with that. Okay. Is that fired to it? I do not know. Easiest way is let's go down monitor it. Monitor it. What have we got? Oh, right, we've got channel 1. We ain't got channel 2. Where did he go? Oh, it's because I thinged it, didn't I? So upload. So there it goes. Let's watch it upload. Bum, 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 bum. Yeah, that's uploading. Oh, serial monitor. Okay, how's this? Right, channel 1 we've got 3.31 volts, which is as I said, I connected to 3.3 on the channel 1. Channel 2 is just floating. So we got that. This is all for the serial. Hope you found that useful, because what we'll do now is we'll in the next episode is we'll add a display, and we'll just start with the default sketch for the display, and we'll get this display working and then almost like merge both sketches, and then we'll have basically the voltage in, which will then be displayed on one of our displays. Okay, many thanks for watching. Don't forget to tune in on part 2, where we'll go into the display. Many thanks for watching. Don't forget to subscribe, and see you soon.